Good day. I'm Tom Robertson with the International Emergency Management Society. I'm here today to teach a virtual training course in best practices and recommendations for cultural heritage resilience. The objectives of this course are to review and summarize some best practices developed by the Heracles project. During the course of the project, a number of these practices were developed. And we're going to talk about the components of these best practices, which are the diagnostic and analytical protocols, operational procedures, lessons learned from user experience, and the Heracles ICT platform. This course is a summary of Heracles deliverable 8.7, which is a reference you can use to get more information. Let's first talk about the components of best practices in Heracles. The first thing I want to talk about are operational procedures. They're at the core of the practices developed by Heracles, and they provide a sequence of steps that coordinates the activities performed by the team working on to make cultural heritage sites more resilient to climate change. The steps as shown here are monitoring and management, threat identification, threat assessment, running climate change models, threat analysis based on climate change models, risk assessment based on vulnerability and exposure, and mitigation. And each of these activities is carried out with the help of several types of individuals, types of personnel. They include, in the middle there, a site manager, and also a number of experts in particular domains of analysis, risk assessment, and climate experts. There also can be project managers that are associated with managing a project, a particular cultural heritage intervention project at a particular site, and in-field users, which can take advantage of communication with the Heracles system. Again, the idea is that the operational procedures specify steps to go through, and each of these users plays a particular role within the steps. During the course of performing the operational procedures, there are diagnostic and analytical protocols that are followed. These are procedures that I'll talk about in a little more detail, but they've been developed in Heracles as a way to diagnose issues, potential issues with cultural heritage sites, and to refine the diagnosis and allow analysis of vulnerabilities, potential exposure, and ultimately to support deciding what kinds of interventions to take with a cultural heritage site. As you can see in this box, and we'll be talking about this in a little more detail, there are strategies associated with being on the site, being able to evaluate the condition of a particular cultural heritage site. There are also some specially modified procedures for quick assessment that allow coming up with an initial assessment without the full analysis that typically characterizes these. And also some laboratory analysis protocols that take advantage of instrumentation within laboratories that can be used. The protocols include both sensors, very local sensors, and as well as remote sensors, satellite multispectral, for example, optical or infrared remote sensing, as well as local meteorological sensors. Another part of the diagnostic and analytical protocols are models, and these models allow, for example, hydrological models allow assessment of potential for damaging floods, where areas of cultural heritage sites are vulnerable to floods and so forth. Models are also used to characterize the strength of structures. Are cultural heritage structures in danger of being collapsing, perhaps, either imminently or with being faced with, say, potential earthquakes or stress from atmospheric events, from weather, or from anthropological stress, people, visits, that sort of thing. Climate change, of course, is a central concern of the Heracles project, and climate change models are part of the protocols in order to develop a better understanding of what is to come in terms of stress from the environment on these cultural heritage sites. Anthropogenic pressure and geomorphological pressure, these also can be modeled and used as part of the decision-making process of what's vulnerable, where do we best put our limited assets for cultural heritage preservation. A number of instruments are used as well, part of the protocols, and an important feature of the Heracles approach is that it's holistic, in that we use instruments of a number of different types and provide a mechanism to be able to combine that information to come up with the best decisions. These important protocols that support the procedures are another key element of the practices that Heracles have developed is information and communications technology platform, ICT platform, shown here. It includes elements including data visualization, which allows people who are concerned with a cultural heritage site to be able to access a variety of sensors, the data from remote sensors, information from laboratory analysis, and so forth. Central to the platform is a knowledge base, which is a very flexible repository of all the knowledge associated with cultural heritage sites being considered in the Heracles project in order to try out the Heracles concept. We have 4 cultural heritage sites. However, this general approach is intended to be generalizable to any cultural heritage site. So the knowledge base is there to provide a very flexible means to record information about the sites, about the ongoing analysis, about decisions that have been made to carry forth preservation, conservation, that sort of thing. Another key element of the ICT platform is a document management system. And this is an important element that coordinates activities that are being performed by the various cultural heritage professionals that are working together. So, for example, a site manager may be trying to make a decision about whether to go forward with reinforcing a particular cultural heritage structure, and that site manager needs more information about the health of the structure under concern, or perhaps about the potential for weather that will be stressing the structure. In order to get this information, the site manager needs to find and engage a specialist, a domain expert that can perform the analysis. That expert needs to then be tasked to do the analysis. The analysis needs to be done. The site manager needs to be informed when it's finished, and the site manager needs to get access to the results of that analysis. So there's information that flows there in a coordinated way as the steps for the operational procedure are followed. And the ICT platform and its document management system is part of that. It coordinates that and allows reports to be created, reviewed, initiated, and so forth. Another element of the ICT platform are CAPS messages. Common Alert Protocol is what CAPS stands for. And these are messages that can be used to alert personnel engaged in cultural heritage maintenance to potential issues and enable work going. Another key element of the platform is the risk management workflow. Now, the whole activity of monitoring cultural heritage sites, assessing their vulnerability, analyzing how they're exposed to various pressures, assessing their state, understanding how the materials are going to react and what might be needed to remedy those. That whole process is identified in Heracles as risk management. So when we say risk management workflow, we're talking about basically the whole enterprise that involves all of these types of cultural heritage professionals that we've talked about. And there's a very particular set of tools within the ICT platform to manage this risk management workflow that further coordinates the work that everyone needs to do. So it identifies steps. It makes it easy to, if it's time for a risk manager to identify a domain expert, the risk management workflow, for example, automatically provides a list of managers, of domain experts to select from, and so forth. So in this way, the management workflow facilitates access to the ICT platform so that the information needed for the particular step is made readily available. And this is a great complement to the general knowledge base access, which is very, very powerful, but it requires some, you have to know where to look because there's so many options of information to get. But the risk management workflow allows the user to be pointed, be led to the information and next steps that they need to do. So it's a very powerful element in the ICT platform. So to summarize, we've talked about 4 components of the Heracles best practices: users, operational procedures, diagnostic and analytical protocols, and the ICT platform. And so these are best practices in the sense that the approach represented by these elements has been developed in Heracles. It's been tried out on 4 particular sites. However, it is intended to be a pattern, an approach that can be used for any cultural heritage sites or group of sites that might be under consideration by a particular group. So next, I'd like to talk more about the diagnostic and analytical protocols, which are kind of the scientific heart of Heracles and the Heracles approach. As I mentioned earlier, the Heracles approach is, first of all, holistic. As you can see In the center of this diagram, the Heracles approach allows you to define the current and future state of the cultural heritage site, and also to be able to identify how it's going to be, the monument, say, is going to be impacted by the various pressures that are put on that. At the top, you can see the sensors that are part of what informs these decisions and this analysis, and they include things like radar sensors that can be used to identify deformation of ground or physical structures, optical sensors which can also identify health of materials, configurations of structures and that sort of thing, and multispectral sensors which allow further refined analysis of surface materials, of degree of saturation, that sort of thing. Going clockwise from the satellite and more remote sensing, they might be close, but they're still not as close as the in situ sensors, which include things like meteorological sensors, so that you have weather sensors, weather stations right near the cultural heritage site. Ground and structural sensors that can sense the situation with the inclination of the ground, the softness of the earth, the saturation, that sort of thing. And then finally, microclimate sensors, which can be very important with an important factor in the resilience of cultural heritage sites because of the effect that these interior microclimates have on the surface materials of walls and artworks and things of that nature. Going back around the other way, as I mentioned before, models are an important part of this because models provide a predictive aspect here. So, for example, predicting what the impact of severe rainfall would be on a particular site might take advantage of hydrological models that predict where the water flow will go based on the terrain models. Another particular model might model the impact on structures of various stresses. So, for example, if hydrological pressure on a wall, perhaps geological pressure because of changing situations on slopes, that sort of thing. With structural models, you can simulate the impact of such pressures on structures and predict, is there going to be a problem? Will it be strong enough to hold up to it? Down below the green model box, talk about some portable techniques and methodologies that are part of what Heracles developed and tried out to characterize the particular properties of structures. You know, after all, cultural heritage site preservation and health is a lot about structures. So different types of instruments are used to assess physicochemical, mechanical, and structural properties. So the point of this analysis is that by looking through the eyes of these sensors, making predictions through these models, those concerned with preserving cultural heritage sites can develop mitigation and prevention actions that will give the cultural heritage sites a better chance of surviving into the future and do a good job of prioritizing limited resources that we have in order to keep these sites going. Next, I want to emphasize the multidisciplinary approach here. One of the important aspects is that, as I mentioned, although the diagnostic and analytical protocols are intended to be generally usable to to any cultural heritage site, there still is, it's important to tailor how and which of the wide array of available tools you might use. So in order to do this tailoring, it's important to get clear about some key elements of what you're doing. So first, you need to describe the aims of the diagnostic and analytical strategy and how that meets the need of the users, the particular people, the site managers, perhaps project managers that are requesting the diagnosis. So it's very important that you select analytical approaches, which sensors to use, very much driven by the particular concern that has been expressed by, say, the site manager, and also really tailored to the specifics of the monument asset. What kinds of pressures are it is exposed to? Is it a heavily visited site with concerns about traffic from visitors? Is it a fortress on the sea that's continually exposed to wave action and so forth? Also, knowledge of construction materials and its weathering state is also very important. Very often you can find an interesting evolution of materials. So, for example, in the Palace of Knossos, which is one of the cultural heritage sites examined by Heracles, the original site was discovered through archaeological expedition, and then the original parts of the site was purposely turned into a place where people could visit and really experience as much of the early culture that was used during the life that this site was used. And so there were a number of reinforcements, reconstructions, augmentation to what was found buried in the archaeological site to give the visitors a better idea of what it would have looked like when it was occupied and used. Well, what that created was a combination of materials, both original materials that were placed there, become part of structures that were when they were originally built, and then augmenting materials that were added centuries later to augment the original site and make it easier for visitors to visualize what the site was like. And so these two types of materials, the original and the augmenting, often interact in ways that can actually in the long term cause damage. So factors like that need to be taken into account. Another part of tailoring is really homing in on the selected zones and elements of significance. And this is something that needs to be agreed ahead of time before spending the time and resources to actually make measurements or do analysis. And then based on really understanding in the first bullet what questions you have and what questions you're trying to answer. Secondly, really where the issues are. And that finally you need a well planned out outline of here are the sensors I'm going to use, here are the diagnostic and analytical methodologies I'm going to use to address the specific purposes of these um, of this particular project. So, for example, uh, uh, the Italian medieval town of Gubbio has a number of sites that were subject to analysis in the Heracles project. The Gubbio Walls is a particular example, and the particular issues that were faced there included a need to assess structural health. There were hydrological risks associated with underpinning geology, and also um, the potential for movement of soil that was and hills that were up against it. And so the and broad, the Gubbio walls cover a fairly large area, and within those large areas, they are subject to a number of stresses. So for this particular example, there were quite a strong use of the holistic, multi-analytical approach, where satellite, now on the left of the diagram, satellite radar was used to look for small and large scale surface deformation. Optical remote sensing, as well as close-in sensing was used to look for geometrical features in order to assess the health of the structure. Is the wall leaning? Is the wall is the angle indicating structural movement that is a problem? There's ground penetrating radar, GPR, is used to electromagnetically sense the condition of subsurface moisture and therefore strength. There electrical inspection of subsurface activities, and then an inclinometer, which is a fairly local thing, allows you measurement instrument allows you to make precise measurements to track the change of leaning structures and so forth. And with these kinds of measurements that go all the way from right next to the structure to space, this provides data that can feed models to assess the hydrological risks, what kind of pressure will the walls be placed under, and also how healthy are they right now, where are they weak, where are they most vulnerable. And so that left side there is really looking at vulnerability and what might, how vulnerable are they? Now on the other side, there was, in addition to the risk and the structural health, there's a concern with material degradation. The structure could be just fine, but walls could crumble because of interaction with atmosphere and other stresses. So that right-hand side then was informed both by long-range sensors such as optical and visual and near-infrared remote sensing that allowed analysis of the geometrical features and materials. Satellite multispectral is a technique where you are essentially looking at areas of the Earth and the response of those areas to reflective radiation in various wavelengths, and the pattern shown across various wavelengths is indicative of the surface material and also its condition. And then local meteorological measurements such as rainfall, temperature, humidity, pollutants, solar radiation, all these things sort of set up the context that these materials composing the wall were facing. Now the wall itself was subject to some close-in analysis, for example, drilling resistance measurements, assessments of composition, structure, morphology, physical properties, mechanical properties by taking sections of the wall, taking them into a laboratory. And then another aspect of Heracles was the development of new materials for protection and consolidation to combat issues associated with these, and to allow techniques to assess new materials and be able to predict, are they going to help in the field when we use them for improving the lot of these. So a characteristic of the protocol is that it can lead to a fairly considered and extensive analysis. And so one of the innovations associated with the Heracles project was a modification of this protocol for quick assessment. And so basically this primarily makes use of in situ sensors for measuring meteorological and microclimate data, also to acquire information on ground structural state, and then portable instruments for the use of characterization of materials and their degradation state. So this would allow rather rapid assessment and information required to assess the health and help inform what sort of actions should be made taking forward without having some of the delays associated with more extensive analysis in the laboratory. The Coles fortress, which is shown there, it's in Heraclion, and it's the one that's set on the constantly under the pressure of waves and so forth. So this, we used wave gauges and models to assess the risk and the structural health. The local meteorological measurements, such as rainfall, temperature, humidity, pollutants, solar radiation, were taken and available. And then a characterization using portable equipment of material degradation was used, drilling, resistance measurement, surface topology measurements, and some particular instruments that were used to provide a rather quick assessment on the weathering state and how quickly it was progressing in this particular monument. As I mentioned earlier, laboratory analysis complements the sorts of analysis we can actually do in the field. And in diagnosis, we use both. At the sites, we've got sampling, measurements, and we can map the configuration of the particular site or monument under investigation. We also analyze physical properties, material properties in the lab, mechanical properties, and chemical properties. These are all things that can predict degradation. So our analytical strategy then has these three main elements. First, material composition, the material structure and texture, and physical properties of the material. And as you see listed here, there are various measurements that are used to get a handle on each of these three elements. In particular, the Palace of Kenosis, which is, I mentioned, was one of the places, one of the cultural heritage sites we considered for Heracles. These are the instruments that were used there. You can see there's quite an array of instruments that inform the assessment of the materials there. All right, next I want to turn to operational procedures and talk about them. We've just finished talking about the diagnostic and analytical protocols. As I mentioned, that's kind of the scientific core of the best practices developed in the Heracles program. And now I want to talk about the operational procedures. As I mentioned before, these procedures provide a set of steps that cover the entire enterprise of monitoring the cultural heritage sites, identifying when there's a threat, assessing the threat, doing the kind of analysis that can help assess the risk, and coming up with a mitigation plan. So as you can see, these are the steps within the operational procedure that's spelled out in step-by-step in detail, and also supported, as I'll talk about later, with workflows and other tools in the ICT platform. So these procedural elements include, as I said, monitoring and management, which is keeping track of the health of the cultural heritage sites. This is an ongoing activity. When a threat is identified, that kicks off a set of actions to really decide how serious it is. That's threat assessment. Again, since Heracles is strongly concerned with climate change models, climate change modeling is important. You know, the history of climate pressures, weather pressures on a particular cultural heritage sites may not be predictive of what we will see in the next few years. So these climate change models can allow us to account for a greater number of extreme climate events. Threat assessment based on the climate modeling results, identifying how vulnerable a cultural heritage site is to the sort of environmental factors that will be exposed to in the future, and then assessing finally the risk, the overall risk, and based on severity, determining if what kind of mitigation practices should be done. To just give an idea of some of the breakdown of these procedural elements, main monitoring and management steps. This includes things like identifying alteration factors that would affect the monument, observing macroscopic alterations for exposure estimation, monitoring the asset through sensor data available and sensors. And as you'll see, the ICT platform provides a wealth of information from sensors about any of the cultural heritage sites that are under consideration. categorizing the alteration facts affecting the monument, which ones are the most important, which observations are most important, and coming up with a correlation matrix that relates the factors affecting the monument and the observed alterations. In other words, getting a handle on what the pressures are and what the particular effects they're having on this monument. The next main step is main threat identification step. So the threat identification is next. So once we're alerted, we might create or receive a warning notice. Again, I mentioned earlier that there's a particular messaging protocol available in the ICT platform to have this, to be able to carry this out. Once a warning notice, once we're now alerted that there's a threat, identify the need for on-demand analysis or perhaps climate change risk analysis. Get an update on the current health of the cultural heritage site. This can be used by reports that have been created in the process of monitoring. And as I mentioned, a part of the ICT platform is the knowledge base. And this knowledge base, or KB here, provides a means to get at that data. And then identifying the climate change induced threats and hazards that may impact current health, either because it's already pretty vulnerable, not so healthy, or the hazards are going to be increased because of climate change. Threat assessment is the next step, and this is where coordination among the members of the team is important. So the up until this point, the monitoring and the identification may have been carried out by the site manager, and now it's time to engage the domain experts and start using the diagnostic and analytical protocols such as in situ analysis, the ex situ or lab analysis, running models, and so forth, and deciding whether this analysis backs up the need for further analysis because of the potential risk. Run climate change model is not a complicated step here. The models, of course, could be complicated, but it's called out as a separate element in our operational procedures because of the prominence of climate change as a driver, as a for issues with cultural heritage sites, as well as for this program itself. Then there's a threat assessment based on the climate change modeling, and so taking the assessment of the state of the cultural heritage site based on in situ and ex situ analysis, we can run models and identify where our biggest impacts are. As you can see in this table down the left-hand side are various assessments of cultural heritage health: excellent, very good, good, bad, very bad. And across the top are impacts. And the color coding there, as you can see, if you have a cultural heritage health that's very bad and a very high impact hazard, of course the threat is very high. You might have a good health, but if the good cultural heritage health, but again, if the impact is very high, you still have a problem. So this allows a way of combining the information of the severity of the threat and the condition of the cultural heritage, Oh yeah, this is the cultural heritage table that I just mentioned, and it shows the correlation between health and direct impact. Now, next step is risk assessment, and this is based on assessment of a vulnerability. And vulnerabilities, again, this is done by a domain expert, looks at vulnerabilities for particular elements of each hazard. You know, it could be the particular multiple structural aspects. It could be particular materials that are represented in the structure. The exposure assessment looks at including socioeconomic exposures and calculating based on the multiple factors and overall exposure value. Risk estimation then is based on a combination of vulnerability and exposure. As you can see in a chart here, there's high vulnerability, high exposure creates a very high risk, and various combinations reduce or increase the risk. Final step in the operational procedures is mitigation, and this is an activity that requires developing a plan and involves multiple actors. Often there are the community of people engaged in this expand beyond the particular site manager. The people who are concerned with cultural heritage conservation at a particular site may need to interact with the local authorities, with funding sources, with contractors to do work, that sort of thing. And so all this needs to be brought together in a plan, overall plan. Okay, so as I mentioned, we talked about the diagnostic and analytical protocols, and we've talked about the operational procedures that sort of move things along and provide a coherent set of steps. Now let's talk about the Heracles Information and Technology Platform. What this platform does is it provides an interface. So the sort of outer layer of the ICT platform is called the integrated dashboard, and that is what these users interact with, and it allows them to gain situational awareness, to be able to access sensors that sensed data about particular sites, and it provides decision support by helping the actors walk through the steps required to come to a good decision. There's also a mobile app associated with it that allows for communication in the field. One feature is that although the site manager, for example, who may be in charge of the overall risk management approach, may be quite frequently interacting with the ICT platform. The domain experts are frequently in the field, in the laboratory, doing their results, and actually using their own information systems for analysis and so forth. And so what the integrated dashboard provides is a means for them to do this offline work. Offline is from the standpoint of the Heracles platform, and bring the information back and make it part of the knowledge base of Heracles so that it can be accessed by the people who need that information. Underneath the dashboard, so to speak, are sort of the internals of the ICT platform. They include the knowledge base, they include sensor data, the workflows that help guide the operation of risk management, geophysical data. There's a geographic information system there. And there's a document management system as well that helps the flow of information between, for example, domain experts who are doing analysis and site managers who are faced with making decisions. As I mentioned before, the experts perform their analyses offline with in situ and ex situ analysis and running their models. And so this is a way to help this collaboration between the specialists and the decision makers. I'm going to show you a few screens that just gives you a sense of what it's like on the integrated dashboard. When one logs into the system, there's a very nice geographically oriented interface here, and you can see the screenshot's not totally clear. It's clear on the system, but there's near the middle there, you can see a yellow dot that represents the location of the Gubbio site, one of the cultural heritage sites. And through this interface, you can zoom right in and see a detailed map of the elements of Gubbio and the cultural heritage structures and so forth there. And the top menu across the top gives you an idea of some of the information that's accessible here. Sensors, there's a link that allows you to get sensor data. I'll show you in a minute how some of that sensor data is accessed. There's analysis, knowledge base. I mentioned before that that's a key element here. Then the various the four cultural heritage sites that were used as a basis for trying out the Heracles ideas are shown next. The Venetian Fortress, Palace of Knossos, Consoli Palace, which is in Gubbio, and the Gubbio Walls. There's a interface that allows creation of common alerting protocol messages. Alfresco is the document management system used as part of this. The RM is the risk management workflow. And finally, the last pick is semantic fusion that allows for accessing the knowledge base in a particular systematic way. The data visualization interface is really quite powerful, and this is a little bit overwhelming. If you look closely, you can see that it represents a wide number of sensor data, and this particular screenshot shows all of it over a period of time. But what you can do is it allows you to select one or more sensors and show it over a period of time that you can define, and also to associate it with the geographical location you're interested in for the cultural heritage site. So it's quite a powerful data visualization tool. I mentioned that risk management workflow is an important element here, and won't really go into it in a lot of detail right here, but this gives a basic schematic of workflows. And so it's possible to define workflows with the system, and once you initiate a workflow, for example, for assessing the health of a cultural heritage site, it guides you through the steps required to do that part of the workflow. It facilitates connecting with the people that you need to work with, and it facilitates the sharing of information back and forth that support the analysis and decision making required in order to go through the workflow. The document manager I mentioned is a particular application called Alfresco, and it has its own workflow that supports creation, review, and approval of documents, such as analyses supporting particular diagnosis of the risk associated with a cultural heritage site. The knowledge base, as I mentioned, is a very flexible repository of all kinds of information associated with Heracles. And it's based on a concept called ontology, and it contains all this information in a particular way. It's represented as objects or instances. For example, an object could be a cultural heritage site, a person, an analytical model. Classes, a class could be a particular thing like a wall or a site manager, type of damage. Site manager is a class, for example, and a particular person could be a site manager. They're an object or an instance of a class. And the third part of an ontology are properties. This could be the number of visitors, number of sites monitored by a site manager. It could be a location, the property of a cultural heritage site, for example. And then relationships between these things. Something causes another thing, or depends on another thing, or is contained by, the overall Gubbio site contains the Gubbio walls, for example. So the knowledge base allows centralized information of all kinds, information on the cultural heritage sites, information on the diagnostic and analytical protocols, information on modeling techniques, on material techniques, on characteristics of buildings, and so forth. So it's really quite flexible. And there is a way through semantic querying to be able to get to any data you want. However, a more common way that people will use it, particularly users, is they will be following a workflow which provides ready access to the data they need at any particular step. Common alerting protocol messages is one of the items. This is used if a threat has been identified or damage that has affected a cultural heritage site. This alerts that some action may need to be taken. And so this alert is carried out in a CAP message created by a site manager through the ICT platform. There are also CAP messages can be set after a previously identified threat or hazard is now considered to be significant. And then finally, after a threat has been identified and remedied, a CAP message can be sent out to signal that the risk has been mitigated, or previously identified threat was a false alarm. So the CAP messages can sort of initiate and then terminate issues requiring resolution. These are created using interactive forms on the ICT platform, and that's the review of the platform. So finally, to summarize, Heracles' best practices include a number of components. The core of it is operational procedures that help various cultural heritage professionals guide their way through the work that needs to be done to maintain these cultural heritage sites. Diagnostic and analytical protocols, which are the scientific core of the best practices to be able to assess and analyze in quite a lot of detail from many angles and many resolutions what the state of the cultural heritage site is. And then an ICT platform that supports the operational procedures and making decisions, incorporating the results of diagnostic and analytical protocols in order to do it. Another element is user lessons learned, which will, as the experience is gained with the system, users will be able to catalog their experience and add that to the best practices developed during the course of the project. Diagnostic and analytical protocols have been developed reflecting a systematic test sensing, diagnostic, and analytical strategy that is multidisciplinary and multi-analytical. This holistic aspect of Heracles is really quite an innovation. These protocols are general, however, they need to be tailored to specific cultural heritage sites. And one of the innovations within Heracles has been development of a modified protocol for quick assessment. The operational procedures, as I mentioned, have been developed to guide site managers, experts, and project managers in their collaboration to monitor, assess, and mitigate climate-based threats to cultural heritage sites. And finally, the Heracles ICT platform supports all this work by managing data, supporting collaboration, and assisting in decision making. Thank you very much.